Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on scientific programming using Python. Now in this tutorial, we'll be looking at how to do interpolation operations in Python. Now, before we start with, to do interpolation, we need the help of an array called SciPy, which is available in Python. It's actually the short form of scientific Python. Okay, the library. Now this has a lot of advantages, features, and a lot of functions, which does a lot of operations that which we can use quite extensively for our operations. So let's begin that. Okay, ignore about this line, it's not necessary. Now what we need is that we need to import a library called as a class called as interpolate from the module scipy. So how do we do it? I do this by including this line from scipy import interpolate. So if I copy this and paste it over here, yeah, perfect. Now we have the interpolate class available in scipy. Now let's create a now this example is actually a sample example available in scipy documentation, so I kind of use that the same. Okay, hoping that this won't cause any issue. So anyway, like what I'm going to do is that since with numpy I'm going to create an array whose values whose numpy array whose values range from 0 to 10. Okay, between 0 and 10. So you'll have an array which whose values range from 0.0 0.0 to 9.0 except 10. So I copy this and I paste it up here. And if I look, okay, now variables are just too many numbers, so let me delete all that for now. Okay, now if I do the same operation again, I'll be getting a float value x whose value ranges from 0 to 9. Okay, but it's a float, you have to keep in mind. Okay, next what I'm going to do, I'm going to set y to be a function of x. It is an exponential function of minus x divided by 3. Each value of x is going to be divided by 3, and okay, and then the negative of each value of this function will be multiplied with minus 1, and that will be used as the power of that value will be used as exponent of the function x. So what I'm going to do, I'm just going to copy this and paste it here, and if you look at the y values over here, you have a decreasing trend of y values like this. Okay, now let's do the interpolation operation. So how to interpolate is that first create a function handle, say f. Okay, function handle f such that the values are matched. How do we do that is that let f create a function handle like f equals interpolate, which is this, dot interpl1d, meaning this will be the interpolation function in one dimension. Okay, and when we do this, we are going to set the integer input value to be x and the output value to be y, and this is how the y handle is set. This is how the function handle f1 is set. Okay, so what f does is that if we input an x value, it will input an x value. It will based on how the x and y are connected between these two. Okay, I think I'm messing up here. Let me explain this. You have an input value and you have a function or a distribution given in terms of x, one dimensional distribution given in terms of x. Fair enough. Now what does this f does is that it's going to create an interpolate interp1d function such that it will be based on the input entries x and output entries y and the relation between them. Okay, that's how f will be. Now if f is set in such a manner that if you enter some value which corresponds to x, okay, this f will return out on a variable which corresponds to y, which more or less maintain the same relation as x and y. Just watch. Now what I do is, after the f is being done like this, okay, I set x1 to be numpy dot linspace 0 comma 9 comma 100, meaning creating 100 linearly 100 points between 0 and 9, 100 points between 0 and 9. So what I do, let me copy both these functions, copy both these lines, paste them over here, enter. Now if I type f, what will I get is that I'll be getting what I get is that it is a function interpolation handle. Okay, whereas x1 is actually a value which a function sorry, x1 is actually a value, an array which has 100 points between 0 and 9, including the linearly space between 0 and 9. Okay, and now why if I pass f of x1, okay, it is going to return me y1, which is interpolated, which will be interpolated. So if I copy this and paste it over here, you'll get a return value called as y1, which will vary between 1 to 0.05, just like how y valued between 1 to 0.05. So if you notice in this, because of creating a function handle like this and making sure there's a relation existing between x and y, as this, if you just input an x value, if you just input an x array into the function handle, you'll be getting a y array as the output. This will return a y array which can be assigned to a function like this. Now what I do, let me plot these functions one after the other. So if I use plt dot plot x comma y comma with what do I do with it? Yeah, just give an o with o. Okay, if I enter, you will get a plot like this. Okay, you will get a plot like this. This is the one-dimensional plot. On the other hand, if I were to do the same with x1 y1 with red dash, see what happens. I'll be getting points such that which are equally spaced between which are much finely spaced between these points. Okay, that's about it. Okay, now that's about it. So x1 and y1 are the same values of such as x and y, but they are much more closely packed and much more nicely interpolated. And that's about it. And that is how you create that you make an interpolation, one-dimensional interpolation. You create an interpolation handle like this with an input and output and a relation between them. Okay, and once this is done, pass an x handle into it, to the function handle, interpolation function handle, and it will return a y array out of it, such that the sizes are maintained and the same functional relation between the initial inputs used for defining the handle is maintained over here. And that's it. And that's about linear interpolation. And they also have another option called as two-dimensional. You also have a 2D interpolation. That is again simple. What you need is that you need two inputs this time, x and y. I'm setting the x and y to be numpy values of range minus 5.1 to plus 5.01. Okay, with space between them to be 0.25. Now if I were to plot, okay, let me delete the variables first. Console. So if I were to paste this up, okay, I'll be getting 41 entries. Okay, between x and y, and then this command creates a mesh grid. I'll explain what's going on. Now np.meshGrid is used for takes two arguments x and y, and it's going to make return two values xx and yy, which have grid name, which are grids, which are 2D in nature. So if I were to copy this, paste it over here, okay, xx will be a 41 by 41 square matrix, 41 by 41 square matrix with the longitudes, with the latitudes present, just like how the with all the variations in x-axis repeated 41 times. The x-axis values are repeated 41 times, and then yy, what you'll have is that you'll have all the values printed. You'll have all the values printed in y-axis, but the y-axis is repeated several times. Y-axis repeated 41 times over here, thereby creating some kind of a mesh. So if you just plot x, if you just have a 2D plot or something in x and y, if you have a 2D plot, it will work out nicely. Now watch. Now this has been done. What I'm going to do is that I'm going to create a two-dimensional contour field such that z equals x square plus y square, something like a circle. And if I were to plot this up, z equals xx power 2 plus yy power 2. Okay, now z will be a two-dimensional matrix. Will be a two-dimensional matrix whose values are all positive but range from 0 to negative. Okay, like this. Let's see. Okay, now what I do is that now I create the interpolation handle, just like I created the interpolation handle for 1D, but this time I'm using the function interpolate 2D. Okay, and now what I do is that I just set the interpolation kind to be cubic, and the input arguments are xx and yy, okay, xx and yy, whereas the output argument is z. Okay, I am passing these values into here so that I am connecting the inputs and outputs to create a handle like this. So let me create the handle, and then if I copy this and paste it over here, it will take some time. This interpolation will take some time, so sometimes you may get an error, like you get a warning, something like this. Okay, so you may get a warning, but don't worry about it as of now. Okay, now let's create some finer points x1 and y1. Okay, let me paste this up. Let me paste this up. Okay, now if I copy this line, z1 equals f of x1 comma y1. Okay, this z1 equals f of x1 comma y1. Okay, now if I do that, f is actually a method, creating a method. Now if you look at that, z1 will be if you look at x1, it's 1002, y1 is 1002, but z1 is 1002 cross 1002 matrix, just like this, and it's again interpolated. Don't worry about how the link of x1 and y1 is given over here, but it doesn't matter. But if you look at it, the interpolation is done nicely. And if you let's plot this up to see how things go by. So if I were to plot contour f xx comma yy comma z, press enter. This is how the contour looks like. Not bad. Okay, not bad. Okay, the aspect ratio is not set to be equal, so it's like this, but not a problem. It's good. The aspect is good. Now what I do is that let me plot x1 comma y1 comma z1. So plot that. The plot is fine, except that you get a slight distortion here and there. I mean, this distortion is because of the it's because of the warning that we get over here. It says that s is kind of there's something called as some spline operations are a little weak over here, and that's why we're getting a result like this. Okay, and if you want, you can avoid this as well. So you can set this, you can correct this up. How do I do it is that I just set f dot interpolate dot interpolate 2D. Now if I don't know what's going on, so I press control I. Okay, it says that you have x, y, z kind equals linear copy true, bounds error false, fill value none and everything. It also gives you a sample example of how to do all of this. Okay, now the thing is, by default it takes something called as linear, and it takes cubic, and it takes quintic. Okay, what I've done is that it even gives you examples. Oh look, I'm using the same example that is given over here to do all these options. Okay, do all these options. So what I'm going to do, instead of cubic, let me copy the same thing, but instead of cubic, let me type quintic to see what's happening. Paste it here, and then quintic, right? quintic, quintic. Okay, this will take time. It's still showing some warnings. Okay, now if I just repeat these lines over here, copy paste these. Okay, z1 is done. So if I plot x1 comma y1 comma z1, yeah, perfect. Now the plotting is proper. Since you may have to go for a higher level of interpolation because based on the function, that is it. Now the plot looks proper. And now that's all I have for you guys in this interpolation tutorial. The next tutorial we'll be looking at something called as regridding. We look at regridding data, and then after that we look at streamline plots, and then quiver plots, and then how to save and read data from mat files and everything. Okay, that's what we're going to do. So thank you guys for watching, and I'll see you guys next time.